Hello everybody, so today I will talk about physics. The topic today is about frequency, wavelength. So now I will show you the answer. Question number 1a. Determine the frequency. The formula to find the frequency that should be about F equal to 2p divided to omega. Omega, that's about angular frequency, and we know that omega, that's about 2p in here, and you got about 1 hertz. So we put number 1 in here. Question B. Determine period of the motion. So we have capital T equals to 1 over F. F we just calculate in here. That's about number 1. And we got about 1 second. So we put number 1 in here. Question C. Determine the amplitude of the motion. So the amplitude, that's about capital A. So A, that should be about number 6. So we put number 6 in here. Question D. Determine the phase constant. The phase constant, that should be in here. And we put about B over 4. Question E. Determine the position of the particle at t equals to 0.29 seconds. So we have t in here. So we put number 0.27 0.29 go in here. So you got the answer. That should be about 5.994. Now let's go to the question number 2. In the question number 2, we have the formula to find the periods of the spring. The formula that should be about capital T equal to 2p multiplied with m divided by k. So we have 2p multiplied with m. That should be about number 1. That's about the mass over 49. So we got about 2b over 7. So the next one, we want to calculate the maximum of the speed and the maximum of the acceleration. So we have v mass equals to capital A multiplied with omega. So we have A is about 2.6. We need to convert into the meters. So we have 2.6 divided to 100. You got about 0.026 meters. Omega, we have T divided 2b divided by T. So we have A is about 0.026 multiplied with 2b divide to t in here. So we put everything in here and we got the answer. That's about 0.182. Now the next one, acceleration. We got about A mass equals to A multiplied with omega to the power of 2. We do the same technique and we got about 1.274. Now let's go to the next one. We want to create the function for position, velocity and acceleration. So the answer in here, this is about from 0.026 and we put about cosine. This is about omega. Omega we calculate that's about 7 t. So we want to find Vt. Vt that's about first derivative of st. And we got about negative 0.182 sine 7t. And the next one, At is about first derivative of Vt. And we got about negative 1.274 cosine 7t. Now let's go to the next one. A vertical spring stretch 4.2 centimeters when a 14 grams object is hung from it. The object is replaced with a block of mass 22 grams that oscillates up and down in simple harmonic motion. Calculate the period of the motion. So we need to find the value of k. K is about F divided by S, and F that's about M multiplied with G divided by S. We have M that's about 14, but we need to convert to kilograms. Multiply with 9.8. Then we divide to 4.2. Multiply with 10 to the power of negative number 2. And we got about, you got about 3.27 Newton per meters. So we have T equal to 2B multiplied with M divided by K. So we got about M that's about 22, but we need to convert into kilograms. We divide to 3.27 and we got approximate about 0.515 seconds. And this is the answer for this one. Now let's go to the last one. A simple harmonic oscillator takes 14 seconds to undergo 7 complete variations. So to find capital T, we have small t divided by n. So we have 14 divided to 7. You got about 2 seconds. So that is the first one. B, that is about f equal to 1 divided by t. So we have 1 over 2. And the last one, that's about angular frequency. That's about omega. We have 2bf. So we put about 2b multiplied with 1 over 2. And we got about b. That's the end. Thank you for watching.